Okay, my name is Andrew Eads, and there's a little chat on Mastodon that reminded me I made a presentation a year ago, so I've adapted it to remove any like company details. I've changed company since then. It's called MVVM for Dummies, or what the fuck is a VM? So here goes. So first of all, what does MVVM stand for? M, model. V, view. And then the really weird one, view model. So we're going to explain each of these in turn so that we can understand how they kind of interact together. These three classes or structs or whatever data structures, depends on your language, work in concert together to present a user interface essentially. So what do we mean by model? It's not a toy train. It's really simple. There's my. It's just data, ones and zeros. And the essence of the M in the model means it's a model and of data. It's a data model. So it needs to be as pure as possible. So if you work in C#, it's got to be a completely not derived from anything else, just pure C#. If it's Swift, it's a struct with just data in it. Any other language, it's just data, zeros and ones, really simple. That's the best kind of model. It has no assumptions about anything else in the system. View is pretty simple. It's what the user sees and interacts with. We know that as a user interface in my industry, which is video games. This is the user interface, and essentially a user interface is built out of views in a view hierarchy, which but a view we can consider the entire view hierarchy is also a view. This is declarative UIs like Swift UI make this really plain and simple, clear. Views are views in views and views and views, So, but essentially the MVVM model way of thinking about this, the view is what you interact with as well. So it sends messages back from the user into the system in some way, and it displays the results or whatever, buttons or tables or whatever you want. And we've all seen this kind of thing before. We've all seen views and models before. This is like a simple one. If you imagine I've got a pointer and I'm pointing at the middle of the screen here, you've got a data table, an Excel spreadsheet, and you can from that table, which is data essentially, although obviously it's been presented in a view, but let's forget that bit. We've got essentially some data read off of disk into a table, but we can present it in different ways. We can look at it as a bar graph or a pie chart or any other kind of way you want to think, and that's the difference between fundamentally what a view and a model is. So, and I've helpfully named. So, but the important thing, as we know with Excel, is you can have the same thing and you can draw a pie chart or a histogram or whatever. So the same model can be displayed in different views in a different way, and in be interactive or not. And interactive, a different view might allow you to edit a pie chart color, say, or whatever, and that's might not be, you might not allow that in another view. So, WTF? What is a view model? Well, it's a strange name. It's a model of a view, and that's the essence of it. So because it's a model, it's got to be really simple data. It can't be complex class hierarchy or anything else. It's a model of a view. So what does that really mean? So going back to using Excel as a kind of example, or anything else, but let's say we've got we want to display a name. And although I'm going to be really simple and we're just doing one piece of data turning into one tiny view, because it's all a view is a hierarchy of views, and model can model a hierarchy of data. A view model can also model exactly the same hierarchy that the view needs. So it does get more complex. That's interesting. My air tag's just displaying, pinging. So here's a model, right? Very simple. My name, first name Andrew, second name Eads. Right, that's really annoying. The view model for this could be, and you notice there is a subtle difference here. I haven't just we're going to display this. So the view model is what the model of what we want to display. So we're not going to display the name first and second like that. We're going to actually, do some data processing to process it into Eads, A. That so you can imagine there's a function that takes the last name, first name, and takes the initial and and creates this piece of text. We want that. That's how we're going to view the name in this example. We're also going to assign it a colour as green. We're going to display Eads A in green, and that's what the view is. So that's the fundamental difference. Now if we go backwards through this, you see what we're seeing is green Eads A. That is described by the view model as a model of some text and a colour. And that comes from the actual model from the database of a different set of data, but you can see that we use the model data to derive the view model, and then the view presents that. And that's essentially it. That I know this is vastly simplified for the sake of this presentation, but a word of dependencies are important here, and this is why we separate the view model, and view. Now, what you don't ever want to do is make anything other than anything you want to keep the view away from everything you can. The view is nasty, dirty, outside worldy user land, which is essentially, user interactions is essentially a randomizer, randomizes everything that happens in your program. You want to get rid of that as much as possible and control that interface. At the same time, you're reading a model off of disk or a database or wherever it's generated in code, who knows. But you've got your model and the view, and you want to keep them away from each other. You don't want the model to know about the view or the view to know about the model. And if you see the direction of dependencies is here, the view model is dependent on the model. So the view model knows about the model because it observes changes inside the model. It also can drive change in the model. So if you update the name, you edit your name. In that example, change the colour. The colour's not necessarily kept in the model in this instance, but say I wanted to change my name by default to Brian, then I could then tell the model that the name's changed, and the model would then preserve it on the database or disk or whatever. So we observe, the view model kind of observes the model, but also is able to update the model. So you're going to, when you create these things, you're going to create a connection between the view model and the model. But it's the view model that knows how to connect to the model, not the other way around, because the model needs to be, again, pure and ignorant of any kind of view stuff. And the same reason that we have here is the view renders the view model. So the view model is a description. I like to think of it as, you could write a text-based adventure and just describe. You see a name in green on the wall. It says Eads, A. That is the valid view of that view model. So is just drawing a green name. That's a valid view of that view model. Even like drawing the name backwards is another view of the same view model. Well, no, of the same model, but you'd have a different view model which would have the text backwards, for instance. So if you wanted a different colour, the model stays the same, but the view model changes the colour to red, for instance. And then the view goes, I need to render this as a red piece of text, not green. So the dependencies are here that the view renders the view model which is observing the model. And then all user interaction goes from view to view model. It manipulates some data inside the view model and potentially updates the model. Then all the other view models that are observing the same model can update their view model, and then any changes within the view model are then rendered by the views that are dependent on the view models. And that is how MVVM works. I'm on Mastodon at don't know what I'm at. Can't remember. Matadan, I think. Matadan. But yeah, let me know what you think on Mastodon. Thank you.